Let's have some other values. Okay, proposed values. They are a bit similar, but not exactly the same. Let's have, let's suppose that W1 at time iteration 0 is equal to minus 30, W2 at the same very first iteration is 300, but the bias now, we'll change the bias. For simplicity, we'll just change the bias and make it minus 1230. Okay, so these we keep for simplicity. Okay, but this now instead of 50, we just plug in this value and see how the network behaves. We'll suppose that AGHA is the same, learning rate is the same, 0.01. So let's plug in the values again and draw the boundary conditions. So this again, the same thing that we have done. So x1, 100, we get x2 is 14.1, and when x1 is 200, we get 24.1 for x2. So these are the 2 points, okay? This is 1 point, and this is another point, and we draw the line. But now, you see, there is one problem. The problem is that this value, which is 114 and 15.2, which is actually in class C1, now it's in class C2. So the initial hyperplane does not separate the two classes. Therefore, we need to train the neural network. So this value is a wrong value. And we have to train the network so as to get the right value for the bias. Okay, so that we are able to shift this line here. Instead of being above, we have to shift it below. Okay, to that extent that it separates the values. Let's see how we do this. So we start like this. These are the values. We use the known fruit number 1, which is, these are the values of one of the known fruits, 121 and 16.8. This from the table that is given in the example. Okay, this is x1. Okay, these are the values. This is the bias. Remember that this is the bias. So this one bias and 121 and 16.8. Okay, and we know that the desired output would be +1 because this is actually in C1. And the weights, these are the weights. We start by the wrong weight for the bias. This is the wrong weight for the bias. And this is the weight. This is the wrong weight of the bias. And this is the weight of x1 and the weight of x2. Okay? And repeat the same thing that we have done before. We take the signal. Okay? We just plug in the values, substitute the values. Okay? We find that the value is signal of 180, which is a positive value. We get +1. Hence, no need to recalculate the weights. So, it's apparent here that for this type of fruit, it works well. Okay? So, for the second iteration, which is n+1, which is W1, we'll get the same, take the same weights. We'll not change the weights. Okay? This we'll do in the next slide. So, again, we take the same values, okay? But for another fruit, which is 114 and 15 plus 2. This is the second fruit, okay? Which is supposed actually to be in class C1. Again, we are expecting this fruit, the desired value is +1 because it's in class 1. Let's see if it fulfills the requirement. So again, we substitute the values. Okay, this with this here, and this with this here, and this with this here, and we take the signal function. If we do the algebra here, we can see that this is a minus value. So signum would be -1. This is the actual output, but the desired output is 1. So these two are not equivalent. There is an error. Hence, we have to recalculate the weights. So we cannot take these weights. We have to calculate. These weights are not acceptable now because it does not fulfill the requirement. We'll see how to do this using the steps for adaptation. Here we use the adaptation of weights vectors. Step 4 to update the weight. We have seen these steps before. So this Wn plus 1 is equal to Wn plus eta dn minus yn multiplied by xn. This was our equation. So we have just to plug in the values. We have these values for weights and for ants. Okay, these are the values we got before. So let's now substitute in this equation. So this is our second iteration. So W1 plus 1. So it's W2. Okay. Please note there is a difference between W2 as an iteration and W sub 2. Sub 2 means the second weight. Okay. But here it's the second iteration. So we just simply substitute the values. So this is the weight vector, okay, which you already have from here, and then plus the eta, okay, this is the eta, and then the difference between the desired and the actual. This is the desired minus actual is -1, okay, multiplied by this input vector, okay, and then we have W2 is equal to this value. We just do the algebra, okay, then we add the two vectors. When we add the two vectors, we just have these new values for the weights. Okay, so this weight has changed, this weight has also changed, and the other weight has changed. So instead of these old weights, we have now new weights we got from the training using this equation. So let's apply these new weights to one of the fruits. So this fruit is 210 and 9.4. We apply the new, these are the new weights, and this is the this fruit, and we expect this fruit to be of class C2. So that's why we expect D2 to be -1. So again, I will not repeat the same process again. We'll just plug in the values and see what we get. So we get the signum or the sign of this negative value, which is -1, which is equal to what we expect. So hence no need to recalculate the weights. So we'll use the same weights in the second to check the second fruit. We'll use the same weights. So for this fruit, which is 195 and 8.1, which is in class C2 again, and we expect D3 to be -1. If we plug in the values, we get the signum to be this value, signum of this value, which is again -1. So it equals D3. So no need to recalculate the weights. It's obvious. Okay, then we take the same values. Let's go to the next slide with a different fruit, which is 121 and 16.8, right? Same thing is repeated, okay? And we plug in the values. until we get the signum of some positive value. Now, because it's a positive value, then we expect it to be plus 1. Okay? And this one belongs to class C1. Actually, there is some mistake here. Please just this D4 should be positive. I'm sorry for this mistake. I'll just correct it in the slides. So this should be a positive one. So Y4 is equal to D4 expected, but just change this to be positive, please, because it's actually in C1, so it should be positive. That's why it's obvious, huh? So hence, as both Y4 and D4 are equal, then no need to recalculate the weights. So we take the same weights and we try for some other fruit. We'll try with this fruit, 114 and 15.1, which is in class C1, and D5 is positive. Okay. So we plug in the values and we find this signum, which is positive. Okay, then positive 1 is this Y5 is equal to D5, so no need to recalculate. Everything is perfect with us. We move to last step, okay, to find the boundaries and see if this new or these new values would make our boundaries separable. So these are the values. We just plug in the values which we got with the weights. This for the bias. This is the bias x1, x2. Okay, let's again substitute x1 as 100 and we get x2, and substitute x1 as 200 and we get x2. So these are the 2 points here now. We have 113.32, 222.55. Okay, so this is the line. Okay, now it's very good. Okay, so this line separates the two classes very well. Okay, so this one class and this is another class. So the new decision boundary can now be used to classify any unknown item. So let's use it to classify the given item, which is unknown for us. So let's use it and we'll use the same calculations actually. So this is the unknown fruit which we don't know, 140 and 17.9. So these are the values, okay, and we'll use the weights that we obtained. Okay, these are the weights. Again, we'll use our signum, and we come to a conclusion that the signum function is a signum of some positive value, so it's +1. So we conclude that the unknown fruit belongs to the class C1 because it's positive. Okay, very good. Now our network is doing well and it's able to even predict unknown type of fruit. So in conclusion, we conclude that we could use the simplest form of neural network, which is the perceptron, to classify two different types of fruits, and we can also train it to be able to predict some other new type of fruit and tell us on its own whether it belongs to class C1 or class C2. Thank you for paying attention. It's my pleasure to be with you. I hope everything is clear, and now it's time for discussion. After discussion, I'll be expecting to see you soon in the next lecture. Thank you, and let's start the discussion.